Hi everyone. First of all, thank you very much for attending to this talk. I know everyone is pretty tired. It's been 2 very long days, but I hope the conference has been fun. I hope everyone learned something new. Yay? No? Yay! Yeah, there we go. I'm Rosario. I work on the Firebase team, and today I'm here to talk about, well, Firebase. So just a quick intro. What is Firebase? Well, we like to say that Firebase is a platform that helps developers building better apps. So in short, we have a pretty, not sure if I would say long list of products to help you build better apps. So we usually divide these products by categories. So we have the build ones that you usually use during development. Then we have the ones that we call improving app quality, and those you can use when you're releasing your app and monitoring how your app is doing. And finally, we have the engage ones, which let you engage with your users. So in a traditional app architecture, you would usually have something like this, where you have an app and it connects to your API server through a REST API, or maybe GraphQL. I saw a couple of GraphQL talks earlier today. And then you have this server communicating to a bunch of other servers like databases, auth server, or even media. But in Firebase, we take away all of that complexity from you, and we just give you direct access from the client to the service. And this probably raises some questions about security, and that's the whole reason why I decided to do this talk. So if you're getting started with Firebase, you'll probably be wondering how to set it up on your client app. This is DroidCon, I'm assuming Android. And now, maybe by a show of hands, how many of you has ever set up Firebase in their Android app? All right, most of you. Great. If you haven't, then I'll show you how it's done, just in case. So for those of you who didn't raise their hands and never set up Firebase, this is usually how you start. You go to console.firebase.google.com. You create a new project. You select a name for your project. So in my case, I just say my awesome project. And then optionally, you can configure Google Analytics. So Firebase is titled coupled with Google Analytics to give you some insights on how your app is performing. And once you do that, there's going to be a loading screen. It might take a while to create your project, but believe me, it's usually faster than your average Gradle build. Once it's done, you'll see a screen like this. You can continue, and you get an empty project, a brand new project. So let's go ahead and add an Android app to it. Click on that button right there. You're taken to this nice wizard that asks you for your application ID along with a name, and optionally you can enter a SHA key. And this SHA key is used for dynamic links, Google sign-in, and phone authentication. And the third step is actually in the title of the talk. It's about the Google services.json file. And this raises lots of questions, but I'll get to it soon. First, I want to go to the next step, which tells you to add some plugins to your app and also the Firebase dependencies. So the plugin is called Google Services. Actually, Google Services. And what this plugin does is basically just reads that JSON file from your app and fetches all the values that are in there and uses it to configure Firebase in your Android app. If you're curious about what exactly is happening behind the scenes, the plugin is actually open source. If you want to check it out on GitHub, and you should be able to see exactly what the plugin is doing. But okay, going forward, you just finish the initialization. You're all set. You already have the JSON file. You add it to your app, and then out of curiosity, you might open the file and see what's going on in there. So this is a sample file. This is generally how it looks. And something that will certainly call to your attention is the API key. There's an API key in there, and what is that for? Is that even secure? Why is it in my app? Why is it? Am I shipping this? There's also some other values that maybe you didn't pay attention because you're looking at the API key. There's some other parameters in there like storage bucket and database URL. You might not realize it right now because they seem like just URLs, but trust me, these URLs can be used by anyone to access your database or your storage bucket. So I'll show you how to prevent that. So like I said, those are the common questions. Is this being shipped with my app? Can I add this to version control? Is it secure at all? And when we talk about security, there are two terms that we need to talk about first. Authentication and authorization. Now, does anyone know the difference between these two? Can anyone just shout really quick? Yes? No?
One's who you are, one's what you can do.
Who you are versus what you can do. Exactly. Thank you so much. So, authentication is who is the user, and authorization, what can the user do in your app. So let's start with authentication. And specifically, we'll talk about Firebase authentication. So we have a product called Firebase authentication, and it helps you identify your users. So it gives them a way to sign in the app. And we provide a couple of providers for that. So you can enable signing with Google, Facebook, email and password, phone number, and you can even set up your own custom authentication service. And more recently, we added multi-factor authentication, which hopefully will make your apps more secure. So once a user signs in using Firebase authentication, they will now get a token that they can use, and then this token will be used every time they interact with other Firebase services, and that's how you know that the user that is interacting with the service is someone that you actually know. It's someone that has already registered to talk to your app. And configuring a sign-in with Firebase Auth is, I would say, simple. It's just, for example, for email and password, it's just a single method that you call saying sign in with email and password, and then you just get the result, and you should have a user already authenticated. Or if your app doesn't really require sign-in, you can even use what we call anonymous sign-in, where a user will get a token, even though you don't have that much information about the user. You still know that they're using your app using Firebase SDK. So why do we need all of this? That's for authorization. That's so that we can set up authorization. And for authorization, we have what we call security rules. So a couple of our products have security rules, mainly the databases. I'm talking about Cloud Firestore and the real-time database. And also the other product that also has security rules is called Cloud Storage. And as you may remember from the file that we saw, those are the products that have their URLs exposed on that file. That's why it's so important to secure it. So if you've never seen security rules before, this is what it looks like. I know the syntax can be new for some people, but let me go quickly over this. So this is an example rules for Cloud Firestore. I'm basically what I'm saying in these rules is I have a collection of to-dos, and for each to-do, I will let a user create a new to-do if they are authenticated, and if in their to-do they're also passing, they're creating a to-do with a field that contains user ID. And I want to make sure that he only creates a user ID if their user ID matches the user ID that has been authenticated. And for read, I'm just making sure that he's reading his own to-dos. So I apply the same rule for read, update, and delete. And a really nice feature of security rules that I personally like is the ability to create functions. So I could probably simplify my rules by creating a new function. In this case, I called it isAuthor, which tells me if the user is the author of that to-do that he's creating. And then instead of having that huge line of rules, I can just simplify by calling isAuthor on create and also calling isAuthor on the other operations. And recently, we launched what we call cross-server security rules, which I think you'll probably find it interesting if you're using cloud storage and you're using Cloud Firestore. So the cross-server security rules allows you to use to create rules in cloud storage based on data from Cloud Firestore. So if you've been interested in that for a while, I know a lot of people have. Do check out our blog. It's firebase.blog. We have an announcement post there with some examples that you can follow. Okay, so let's say you've done all that. You've integrated with Firebase Auth, you've created security rules, you've used MFA, you've used cross-service rules. You feel like your app is secure now. So you think now you might be ready to actually maybe commit the file or push it to production if you haven't already. The answer is not quite. So imagine this situation. You have users using your app. They are actual users. They have authenticated, but now they're abusing your app. They're just they're just relaunching the same screen over and over again. They're just doing many reads on your database, and that's incurring costs to you. So how do you prevent abuse? Well, we do that with what's called attestation. And in the Firebase world, attestation is done using Firebase app check. So what app check does is it attests that traffic that is coming to your backend is coming from your actual app. And it does that by relying on existing attestation providers. So I'm talking about Play Integrity for Android, App Test for iOS, reCAPTCHA for the web, and you can even implement your own attestation provider if you want. So to get started with app check, you just need to go back to the Firebase console. There will be a tab on the left that says app check. Once you open it, you'll see a screen like this. So you can go ahead and initialize it. And it's going to ask you for some details. So in case of an Android app, you need to provide the SHA fingerprint that you use to set up Play Integrity in the Play console. So you just copy that key, put it on the console, and in your code, you'll need to add the app check dependencies and add in some initialization code that will make sure that app check and Play Integrity are both initialized in your app. Once you do both of those, then you'll be able to go to the console and you'll probably see a screen that looks like this. So in this case, I'm looking at Cloud Firestore, and this gives you some metrics about how many requests are coming to your backend. And since I'm looking at Firestore, I might see something like this. So you get some data in there about how many requests have been verified to contain that app check that that token that app check is sending along in your app. How many are unverified? So the orange number that you see right there, that should be the number of people or the number of requests that are coming to your backend and not exactly coming from the Firebase SDK. So it's unknown where those requests are coming from. So there's a high chance that it's coming from maybe someone that cloned your app or that grabbed your API configuration or is not using the Firebase SDKs. So as of right now, AppCheck is supported by 4 of our products. So Cloud Firestore, Cloud Storage, Real-Time Database, and Cloud Functions. But you can also integrate in your own custom backend. At the moment, we only have it for Node.js, so it's available in our Firebase admin SDK for Node.js, but we're expanding support to the other languages really soon. All right, you've done all that, and now you think it's time. Your app is secure, you're ready to commit it, and you feel like you can now push it. And I think the answer is a very popular one. I think everyone must have guessed by this time. It depends. So usually for open source projects, we don't recommend committing your JSON file because you probably want people to be able to create their own projects and test in their own self-contained environment. Unless it's a project where you expect people to actually use your resources or populate some data, like for example a crowdsource project, then it probably works well if you commit your Google services.json file. If you work on a small team if you're working in a private repository and you know everyone is going to have access to that, it should be fine. Make sure that you followed all the other steps that I mentioned before, and you'll probably be fine with that. So let's say you followed my advice, you configured everything, you now committed the file is in your GitHub repo, and now you're getting some warnings. What are these warnings? So those warnings usually come from, so far I've seen it coming from the Google Cloud Platform, I've seen it coming from GitHub. There's lots of developer tools who might mistake that API key that you see in there and think that it's sensitive. I kind of wish we had a better naming on that JSON file to call it something else other than API key. Because what happens is those tools see the name API key and then they detect it as sensitive and they can tell whether it's secure or not. So you might get some warnings. Feel free to ignore those if you've already created security rules for your app and if you think that if you trust that you have a secure enough database or storage bucket. So that's all I had for today. If you have any other questions, I'll be around, and thank you.